Good morning, sir.
గుడ్ మార్నింగ్ సార్.
స్టార్ట్ చేసేయమంటారు సార్?
మీరు స్టార్ట్ చేశాను సార్.
ఓకే సార్.
రికార్డింగ్ చేసుకుంటున్నారు కదండి.
రికార్డింగ్ చేస్తాను సార్.
సార్ ఇంకోటి డేటా అనలిటిక్స్ వరకు కొంచెం మెటీరియల్ షేర్ చేయండి సార్ రేపు.
ఓకే సార్, ఓకే సార్. యూనిట్ 1
ఓకే
అయిపోయింది
అండి.
సార్. ఈ రోజుతో యూనిట్ 1 అయిపోతుంది. నేను షేర్
మ్,
చేస్తాను సార్. రెండింటికి చేస్తాను.
డేటా అనలిటిక్స్ అండి రేపు.
ఏ సార్?
రేపు ఇంకో కోర్స్ ఉంది కదా డేటా అనలిటిక్స్ది.
అది అయ్యాక చేసేయమంటారా?
అదే కొంచెం అదిగో షేర్ పిల్లలు అడుగుతున్నారు సార్.
ఓకే సార్, ఓకే సార్. రెండు షేర్ చేస్తాను.
ఓకే అండి. ఓకే అండి, థ్యాంక్ యూ.
I welcome you all students for this session on Unit 2, Basics of Machine Learning. So let us see how the application of, we already started some algorithms in our earlier classes related to that, how it has connected with BFS, DFS and Dijkstra algorithm, how it is going to connect it with the petroleum industry that we have discussed in our previous session. So let us see another algorithm, that is Minimax and alpha beta pruning in the petroleum industry. Like this is also another algorithm which has uh, very important applications in petroleum engineering. So in which areas we are going to use these algorithms and how it is going to be functioned for the usage of decisions in petroleum engineering. Let us get into that. So our concept today is application of Minimax and alpha beta pruning in the petroleum industry. So Minimax is a kind of algorithm which mostly works in game theory. So game means there will be one winner, one loser will be there. So winner is the one which is going to take the optimum decision. Like that could be the most profitable decision, so that he will be considered as a winner. So when it comes to game theory in petroleum engineering, a decision maker is the game winner in the industry. It could not be only petroleum industry, but any industry. You are supposed to generate profit by taking decision. So when it comes to game means you need to prioritize certain parameters which has to be highlighted for the decisions that could provide you economic profit. So this is how the concept works out. Like first of all, you need to you may have plan A, plan B, plan C. Like that, you might have different number of classifications. Out of all, which one should be the best one? Every classification might give you profits, but the one which you are selecting, you are deciding, you are winning, should be the best out of all. So this is how we have to define the decision of that particular uh, node. So when it comes to machine learning, what happens is we need to train your data with the machine. So what machine, how machine will understand is, maybe some you might have different parameters. When you're talking about a project, you will be having drilling will be there, production will be there, reservoir will be there. So you have different areas you need to consider. So out of all these areas, everything is important. Everything, whatever investment you are going to input for any of these areas, you're going to generate profit. But what is the one which will give you the maximum outcome? It could be drilling parameter or production parameter or reservoir parameter. It is up to you. So that particular area will be defined by uh, this algorithm, minimax and alpha beta pruning. So minimax is the concept of going for the best one by avoiding the other related things. That is one way. Advanced to minimax is alpha beta pruning. Sometimes what happens is you may have huge number of parameters, random random parameters will be there, but go on selecting one by one, it will consume a lot of time. So when it comes to minimax, it will go on considering each and everything. So to avoid, there is a logic is there. So if machine goes through that logic, it will avoid unnecessary you know, parameters that has to be considered while it is in Minimax. So you can avoid all the parameters which are not necessary. Rather, you can go in a best short path towards the goal. So ultimately, your aim is to estimate, the best strategy that will provide you the best outcome. Okay, two methods are there. One is Minimax and alpha beta pruning. So it is not just about petroleum engineering. It could be of any area. You can connect this technology that will provide you the best outcome. So let us see. This is a decision tree. What you are seeing on the right side, you may have number of nodes, and you are going to, you have to go through each and every branch to identify which one is prior, which one is not prior. So there will be a confusion. It could be of number of parameters will be there. So all together you need to consider, means it is not that easy. So initially, the process will start. If it is less parameters, you can go with Minimax. When it comes to huge number of parameters, then alpha beta pruning is the good option. So Minimax, a decision making algorithm used in game theory to determine the optimal move for a player in two player zero sum game. So 0 and 1. 0 is the one which we are giving least priority, and 1 is the one which we are giving the highest priority. 1 means succeed, 1 means positive, 1 means yes. So that means you are taking the positive outcome out. When you are go on comparing, decisions will be taken like this. There will be huge number of parameters will be there. Go to the next parameter, yes or no. Next, yes or no. Next, yes or no. Like that, you have to, once you decide to go yes, then from there onwards the direction will change. And from there you have to go on moving step by step, and finally you're going to reach the goal. So when it comes to alpha beta pruning, it is a technique used to improve the efficiency of Minimax algorithm by eliminating branches that cannot possibly lead to the optimal solution. So there could be some random branches, like Minimax will consider everything. So when it starts going on searching for each possibility, the time consumption will be more. So alpha beta pruning is something like we are going to induce a logic into Minimax. So based on that logic, it can avoid unnecessary movement of certain random nodes where it is not that necessary. So you can consume more time. So even though if you consider that, that will not provide the optimal solution, means it just iterates, but the solution will be the same. Without that also the solution will be same. With that also the solution will be same. If you are considering that, the time will be, it will be consuming more and more time that you are supposed to avoid. So how they work in game theory and artificial intelligence. Minimax analyzes all possible game states and chooses the move that leads to the best outcome for the player, maximizing gain and minimizing loss. The concept is always remains same. Like, you need to maximize gain and minimize loss. Gain means 1, loss means 0. In binary configuration, we will take 1 as a positive outcome and 0 as a negative outcome. So maximize gain. So wherever gain is there, it will start moving to that direction. Wherever the loss is, it will start to eliminate that areas. So this is how the concept will start to move ahead. When it comes to alpha beta pruning, it prunes means you will be knowing when we are going through algorithm what actually the meaning of prune. By because pruning is nothing but you are not going forward, simply to say you are killing the node. From there onwards your path have been terminated. So beyond that you are not supposed to, go for noding. So you are stopping for analyzing the nodes. So that is what we name it as pruning. So once you start working with the algorithm, you will be understanding with an example. Alpha beta pruning prunes irrelevant branches of the search tree. So you may have number of nodes in a tree, decision tree or nodal tree. So we have seen these nodal trees in BFS, DFS that we have discussed earlier. Even in Dijkstra algorithm, there is a nodal, uh, 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 you know, what is a structure we have mentioned, nodal kind of structure. So how each node is connected to each other, the pathway, everything we have discussed. That is one example. We have different nodal analysis are there. So uh, these things can be avoided by that. Okay, unnecessary movements of nodals which are not going to provide optimal solution for your overall outcome, that can be avoided. So alpha beta prunes irrelevant branches of the search tree, reducing the number of states evaluated and improving computational efficiency. So this is how it is going to be helpful. So whatever branches, whatever things we are going forward, so alpha beta pruning will avoid unnecessary iterations, which will consume huge amount of time. Okay, that is what exactly. So it will increase its computational efficiency. Why? Because you require lots of softwares input parameters that has to work for each and every nodal tree. So if that was reduced, then your efficiency will start to increase. Application in petroleum industry. These techniques can be used to model complex decision making scenarios in the industry, considering various factors and potential outcomes. So you can see application of this industry in exploration. Minimax and alpha beta pruning can be used to analyze geological data and seismic surveys to identify promising drilling locations. So when you start, like you might be having number of parameters before deciding to the place where you are going to locate for drilling a well. Drilling a well is very expensive, so you need to find out the optimum location so that the drilling should be the best one, considering all other parameters. So which one has to be given priority, which has to be given less priority, that was supposed to be decided by a game theory. That is how we are going to use this minimax and alpha beta pruning. So it is going to analyze geological data and seismic survey. So it takes this as a input parameters. So which one has to maximize, which one has to minimize. So it will start working on the algorithm, and finally it is going to provide you a decision based on a particular location by considering these parameters by using this game theory. Consider factors like reservoir potential, drilling costs, and infrastructure accessibility. So when it comes to cost, that should be given least priority. But when it comes to other facilities like reservoir potential, infrastructure accessibility, and these are all you are supposed to increase the priority scale. So you have to reduce the price, like minimizing drilling cost and maximizing potential capacity of a reservoir. So this is how we can connect it to these algorithms, so that it is going to provide you the best location considering all these parameters. Prioritize exploration efforts by maximizing the return on investments. You can see maximizing, so minimizing, maximizing. So which one has to minimize, which has to be maximized? So returns has to be maximized and investment has to be minimized. So if it comes to exploration, you need to invest less. How you're going to invest less? You need some certainty, you need some data, you need some possibility. So all these possibilities can be obtained by analysis through Minimax and alpha beta pruning. So when you are going to input all the parameters into this algorithm, it will help you to which one has to be maximized so that your return of investment will be maximized, which one has to be minimized so that the return of max investment will be maximized. So keeping that as a goal, it will help you to decide the best things to be maximized, and the things which are not going to provide optimal solution has to be minimized. For an example, a company has identified several potential drilling locations with varying geological characteristics and economic considerations. Minimax can be used to evaluate each location considering potential oil reserves, drilling costs, and transportation expenses. So these are the criteria which has to be maximized or minimized. So this algorithm will work on these parameters and it will assess for each location. So the one location A, location B, location C, it is going to consider the potential of oil reserve, drilling costs, and transportation, and it will provide you the outcome of it, drilling B and drilling C. So out of these three, it will compare and it will tell you which location is the best suitable location for getting the maximum ROI, means return of investment, by considering n number of parameters. That is, one is potential oil reserves, drilling costs, and transportation expenses. But when it comes to alpha beta pruning can eliminate a location with low potential, focusing resources on most promising areas. So this is how efficiency of Minimax will be improved by avoiding. It is like when it comes to Minimax, A, B, C, like that, it will start going on as accessing each and every location what you have. You might give 1,000 locations. So it will start working on all these 1,000 locations. Maybe some locations might have interconnected with other locations. So imagine one location is not giving outcome positive, is corresponding to that there could be some locations where that could also give the same result. So alpha beta pruning, what it will do is it will try to avoid all similar kind of locations which are in negative nodes. So that means if outcome is not being positive, that like that it will try to analyze which are the wells similarly related to that particular where the outcomes are not being positive, and it will try to eliminate them, and it will start moving to the new wells. So in place of going to all 100 wells, it will start avoiding unnecessary wells in between, unnecessary locations in between, and finally it is going to go for the node in very less time. The goal node, it will be, you can able to get the goal node in very less time. Why? Because you are avoiding unnecessary well data. So let us, when it comes to production, so application in production, Minimax and alpha beta pruning can be used to optimize production schedules to maximize output while minimizing costs. Manage equipment maintenance and deployment to ensure efficient operations. Minimize downtime and production disruptions. So this is also a kind of algorithm which we will be using in production for their own connection parameters. So which has to be given highest priority, which has to be given lowest priority. So there are a number of parameters they have. When it comes to an example, an oil field has multiple wells with varying production rates and maintenance requirement. Minimax can be used to determine the optimal production schedule for each well, considering factors like reservoir pressure, well integrity, and equipment availability. So these things will be considered as parameters, which has to be given highest priority, which has to be given lowest. Well integrity should be higher, reservoir pressure should be higher, and equipment availability, that also should be higher. So based on that, it will work on the possibilities and it will start to provide you the best outcome. Alpha beta pruning can eliminate inefficient schedules, focusing on minimizing overall production while minimizing downtime and maintenance costs. So maintenance costs and this downtime time takes to unnecessary things, what are they, that will be considered as downtime. So that has to be reduced, maintenance cost has to be reduced. You are supposed to increase reservoir pressure, equipment availability, so well integrity, and all these factors all together, so you are going to consider and you are going to work on the algorithm so that it is going to provide you the best outcome by considering which has to be given highest priority. So let us start working on this algorithm by nodal analysis, Minimax. So we follow DFS rule. DFS means depth first search rule. So this we already discussed earlier. So we are going to start working on node by node, step by step. Rather, level by level, we will be working on node by node. So you can see we need to start from backtracking, not like directly. See, the goal node is at the top. So what is the goal node out of all? Like imagine these are the outcomes. These are maybe the uh, location places 873. You can give like just it is a number that we have given here. Why? Because we need to represent this with generic form. So I'm giving the numbers. But here you could put any parameters. It could be location parameter 80. So x-axis 8, y-axis 0, like that you can put it. So whether these are the locations, you can understand different wells locations are there. So which location will be given the highest priority? So on what basis? Some parameters should be minimized, some parameter should be maximized. So let us consider certain parameters that has to be minimized, certain parameters that has to be maximized. So this is how we have to go down, and you need to go backtrack. So the one which is above that, this is what these are the starting nodes, and this is the end node. So in between there are two parameter nodes are there. So certain parameters you need to maximize, certain parameters you need to minimize, and finally you are going to reach the one node which is going to give you the maximum outcome. So for that, let us start working on how you are going to work on this node. So we need to go with the concept of DFS. DFS means depth first search. So this is the concept of DFS. So first of all, we need to start working on this. Um, we will start with the left at the last one. So the one which we got it over, the value is 8. So this is a classified value. So that is 8. Numeric value, it is 8. So we need to start moving, progressing towards its parent node. So this is what we say parent node. These are child nodes. So let us go to parent node. See, as we know, depth first search. It is not that it is going to see the best one in between 8 and 7. So based on that, it will not go. So here, let us try to see the above node is related to maximum. So first of all, there is nothing is there over here. So you need to assign your child node to parent node simply. So 8 will be given to the maximum value. Then you're going to see, as per depth first search, the explode value of this is only this node. So you are supposed to compare the value of the one which is connected to your parent node. So 8 and 7. So since it is maximum, out of 8 and 7, 8 is maximum. So you need to consider 8 over here, and you need to ignore 7 here. So you are not going to change the value of 8. Since 8 is the maximum value, you are going to keep it as it is. Then you need to consider this node as explode. So you are going to end iteration. Then after that, next thing, as per the depth first search, this 8 has to move to top. So this is how it has to move to top. This is what we say backtracking. So we are going to end the node here. So the value have been removed, and finally we have reached to this top. From here onwards, you need to go with this decision tree. This is the tree. So you are going to start working on this node. So these three nodes have been already explored. So no need to go back. So 8 was kept here. Again, you have to move through depth first search from this side, and finally this node, either this node or this node. So I'm going to take it the node which is represented as 3. So 3, again you need to take it to the earlier value. So right now 3 value have been taken over here, and we are going to compare with the child node 3 and 10. Out of 3 and 10, which is the maximum? Since it is maximum, a maximum node, you are going to replace 3 by 10. So we are going to replace 3 by 10. From here onwards, you need to compare the earlier parent node. So you already know that there is parent node over here. So you need to compare these two things. But here it is minimum. So out of 8 and 10, which one is minimum? 8 alone is minimum. So you are not going to consider 10. So you need to explode. Leave the value as it is. 8 means 8 as it is. So from here onwards, there is no nodes to explore. Then you have to go for the next parent node. So that is this one. So you have to go to parent node over here. Again, from as for DFS, when you start working on it, it will go to here. From here, you have to move towards this node, and finally you are going to reach to 12. It is not that you have to go only in this direction. You can go like this, and even you can go like this. This also we can go, or else you can directly go over here also, like this way or this way. So you can select any path. So I am selecting this path, so which is on the left side. So always we have to prefer first priority towards the left side. So let us go to the path where the node is 12. So 12 has to be assigned to the parent node. From 12 maximum, 12 to 9, which one is maximum? 12 alone. So don't consider this 9, so you can ignore this 9 and you can keep the value 12 as it is. After keeping the value, it was supposed to go to top. So why? Because there is no more nodes to be explored, so it will directly go to top. So 12, 9 has removed and 12 will be moved to top. From here onwards we have to go to this direction. So from here 11, so 11 will be taken to parent node. From 11 you are going to compare with 15 and you're going to see which one is maximum. So 11 and 15, 15 is maximum, so 15 will be replaced by 11. So when 15 has to compare with the earlier parent node, it should be minimum. So 12 and 15, which one is minimum? 12 alone, so we can remove 15. So 12 will be as it is. And finally the value of 12 and 8, this is the final node, goal node. So we are going to see for maximum. So 12 is here, 8 is here. So which one was supposed to be maximum? 12. So 12 will be, 8 will be replaced by 12. So 12 is your outcome. It is the classified outcome through Minimax. The one which have been won in this game is the node which is named to be 12. So 12 is the one which was supposed to be given the highest priority. So on what direction it has gone through by minimizing all the other parameters, those parameters might be considered for drilling cost or expenses related to maintenance and all that. So you are minimizing. Finally, you have reached to the final goal. So that location which could have the best way of producing crude oil could be the location where the node value is 12. So this is how we can able to take for Minimax algorithm. Am I audible? Am I audible? Okay, so up to now we have gone through this nodal analysis, that is up to Minimax. Then from here we have to go for the next step, that is alpha beta pruning. So this is the path we have chosen. So right now this is about alpha beta pruning. I have changed the values which were at the starting point. So these are not the values of the um, earlier example. So these values have been bit changed so that uh, it will be easier for you to understand how the concept of this will help you. So this is what we name it as alpha beta pruning. So here how we can able to explain this process is the same way we're going to prioritize by maximizing some values, and we are not going to prioritize those nodes which are not having much value towards your goal. So these are the values that have been arranged in between. So we have alpha and beta. So there are two components. These component values will take the outcomes of each node. So alpha means positive, beta means negative. So the least values that has to be provided to beta, and the maximum values that have been obtained that were supposed to be provided to alpha. So this is how we are going to convert. So when you start working on it, we will be comparing the values of your earlier node and we will be fixing the value of that with either beta or alpha, and based on that we are going to take the decision. So you can see the values have been already given over here. So the nodes have been already arranged. So as per Minimax rule, DFS we have to follow. So when it comes to maximum, you can see I have written here maximum as alpha, minimum as beta, and maximum as alpha. So when you see any maximum value, you need to assign that value towards alpha. When you see minimum values, that has to be assigned to beta. So but how you are going to assign it? So let us start understanding this. So as per DFS rule, So you're going to reach to the bottom, that is 8. So 8 has to be assigned over here to the earlier its parent node. If so, from child node to parent node, 8 has to be assigned. So where it was supposed to be assigned, it was supposed to assign as alpha. Why? Because it is the maximum value. So 8 has to be taken as alpha, that is equivalent to 8. So you are assigning the value of 8 as alpha, which is maximum value. Then from this theory, what we have to see is always we need to compare the alpha or beta value of this child node to its parent node. And we have to see the condition whether alpha is equivalent or greater than beta. If it is the case, then you need not go further for the nodal analysis. So you need not go further for the analyzing other nodes connected to that. So this is what it means to say. So alpha is equal to 8. Then next step is, since it is maximum, 7 and 8 it will be compared. As for DFS, the next node it was supposed to compare is 7. And always you have to keep an eye on the node towards its parent node. Whenever right now parent node is empty, nothing to compare. So in further iterations, you will be observing parent nodes. If parent nodes satisfy this condition, then you need to avoid iterating further. That is what we name it as pruning. So let us start understanding. uh, we will be seeing that very soon. So alpha is equal to 8, and the value of this node, that is child node, is 7. So out of these two, which one is the maximum? 8 alone. So you can avoid 7 and you can keep 8 as it is. Then after that what we have to do is, you need to see, after you have assigned 8 and you remove 7, so that part was completed. From there onwards, as per DFS rule, you are supposed to go to top. We have seen that earlier in Minimax. The same way we have to go forward, but here it is minimum. So when the value is minimum, alpha value of whatever earlier child node is there, that will be assigned to beta value. So this is what it shows. So beta will be given as the value of alpha. Why? Because alpha is the maximum value and beta was supposed to be assigned for minimum values. So beta is equal to 8. Again, you come down as per DFS rule and start working on these nodes. From 10, you are supposed to give the value 10 or 3 is there. So 10 has to be assigned to this value, and which was supposed to be equivalent to alpha. So alpha is equal to 10, and we will be comparing 10 value, as you know, that we are not going to compare that. That is the one which we are going to do it in Minimax. But always I told you, we need to cross check with its parent node. So alpha value is 10, beta value is 8. Can we check whether it is satisfying this condition? Alpha is equal to greater than or beta. So that means alpha value is greater than beta value. Then if that is the case, if it satisfies the condition of what we mentioned here, then we need not to go for further analysis from that node onwards. So from that node onwards, you need to kill the node. So you can see from here onwards, there is, even though how many trees were connected to this, that will be all killed. So you have killed the nodes. Why? Because this satisfies this condition, alpha greater than beta. So no need to go further. From there onwards, the value will be assigned same and start moving ahead. So beta value will become alpha. Why? Because this is minimum and the goal node is maximum. So still the goal node was not decided. Why? Because other nodes are there that were supposed to be explored. Then only it will be coming to the final decision. So you have assigned the value of goal node as alpha, since the goal node is at maximum level. So you are supposed to assign the beta value of its child nodes towards its parent node as alpha. Then again, as for DFS rule, come to this direction. The way how we are progressing in Minimax, the same way we are progressing over here also. So from here, the value of the node is 6. So 6 has to be assigned over the next level nodes. Here, what is the value over here? Alpha or beta? It could be alpha. Why? Because it is on the maximum level set. So alpha is equal to 6, which is on the maximum level set. Then again, you have to go as for DFS rule. This is how the pattern will be. So 6 will be compared with 7, and out of these two, which one is maximum? 7. So right now alpha can be replaced with 7. Why? Because 7 is the maximum value. So let us replace alpha by 7. From there onwards, you are supposed to go to the top node, right? Because no more nodes are there to get explored, so you have to move towards top version. This is how DFS works. So when you are moving to top, you're going to see the value. What you are going to give is beta, not alpha. Alpha is equal to 7. When it is going to minimum level, the value of 7 in the alpha node will become to beta node. So alpha value of 7 have become beta value of 7. Then again, I told always we need to have an eye on its parent node. So again, we will compare, since the parent node is having some value like alpha is equal to 8, beta is equal to 7. Let us see whether it will satisfy this condition or not. So alpha, which is 8, is greater than, that is equivalent to beta, so which is 7. So that means going from this direction and iterating further can be simply avoided. You can kill the node. So the value what we have it over here, you can simply kill it. So you need not go for further evaluation. So the final answer for this uh, you know goal node is 8. Okay, maximum value of goal node is equivalent to 8. When you see Minimax, the time for consuming the same level of decision tree is little bit more when it is compared with alpha beta pruning. So when it comes to alpha beta pruning, you can see how fastly we have completed the algorithm. It consumed time. Sometimes what happens is, from here onwards there could be n number of nodes. It could be go on continuously moving on towards thousands and million sets and all that. But if you start just avoiding certain branches, then you can see how much less time we have reached to the goal node. So in this way we can able to come to a conclusion that uh, you know uh, by the help of alpha beta pruning, the path towards your goal node will be more effective than the path which we have taken by Minimax. So what is Minimax? What is alpha beta pruning? How it is going to help us? This is a kind of algorithm that it will help you to move towards the best decision making uh, uh, node. So if you have considered all the child nodes to be locations of well, so which location could be the maximum suitable location for considering all other parameters? Some parameters we have to give highest priority, some parameters we have to give lowest priority. So out of highest and lowest, considering all together, so which one has to be given the highest value, and after even all the locations will be compared with that, and finally they will come to a conclusion at the goal node that even after considering all these parameters, you have reached towards a goal, and that could be the maximum and beneficial beneficially decision making node, which will provide you the best outcomes considering all the parameters. So this is how alpha beta predict. It has huge applications in oil and gas industry, either in exploration, production, reservoir engineering. You can connect n number of parameters. There is nothing to do technically with it. Rather, you have to follow the kind of algorithm. Why? Because technical formulas and all that will be already inside the parameters. So here it is not about defining the parameters, but here it is about prioritizing the parameters. So we are not going to define any parameter by this algorithm, but we are going to give information. Decision making can be taken by the use of this algorithm. So which parameter has to be given the highest priority? Imagine when it comes to an example like porosity and permeability, everyone knows both are important for exploration and production, uh, where the porosity also plays an important role for holding the crude oil volume. But when it comes to permeability, it is the one which will help oil to migrate from one direction to another direction. So both, without oil, there is no migration. So without porosity, permeability cannot exist. So that means porous should be there and it should have enough amount of oil. This also has to be given priority, and permeability also has to be given a priority. But when it comes to game theory, let us talk about two different scenarios. One is exploration game and production game. When it comes to exploration game, we pay more interest on porosity than permeability. The reason is exploration is the game. Our objective is to find crude oil which was present inside reservoir or not. So this is the one we are going to prioritize for. So permeability is the movement of crude oil. So that parameter might not be that important during exploration phase. Okay, we will be finding permeability for certain reasons, but for exploration data, and there is no need for deeper permeability analysis like relative permeability and all that. Just normal permeability value is enough to get exploration data. But porosity will define the volume of crude oil that was present inside the reservoir, so that it plays an important role during exploration phase. But this is how you are going to prioritize that parameter, like porosity parameter, in exploration phase. But when it comes to production phase, so porosity doesn't play much role. Why? Because production means the movement of oil from subsurface to surface. So that could happen with a number of locations, movements from number of areas, right? So where porosity will not help the movement of crude oil, rather the permeability is an important parameter we are going to consider during production phase for the movement of oil from one location to another. So here we are reducing the priority of porosity and we are increasing the priority of permeability. So two different scenarios, two different game theories, two different concepts. Earlier, permeable, like when it comes to exploration, the value of 1 is given assigned to porosity and the value of 0 is assigned to permeability. So 1 0. So highest priority porosity, lowest priority permeability. But when it comes to production, 0 1 means highest priority will be given to permeability and lowest priority value will be given to porosity. So this is how the game theory works. Based on that, switch algorithm, which your objective or goal node has to be assigned considering all these parameters. See, whatever machine learns, that alone will you will get the answer. It is not that it will give you the optimum answer. So you are making machine to learn that this value will be having a least priority for exploration phase and highest priority for exploration phase. So based on that alone, it will provide you the solution. So when you change the priorities, automatically the decision also will change. So machine will learn as per the needs of what you are inputting. So this is how this algorithm like alpha beta pruning and Minimax algorithm will have very good applications for decision making when you are appraising a a reservoir for go for a particular location which is expensive, lot of uh, maintenance, drilling cost, operational cost, investment on the land, so many things, when you consider a number of parameters are required which are more expensive. So that can be focused, that can be done effectively by implementing this algorithm in oil and gas industry. So application of artificial intelligence is always an effective decision when it comes to oil and gas industry. But where exactly you are going to apply and how you can able to understand this, like someone who is a reservoir engineer or production engineer, he might be going through number of challenges related to this decision making activities. Like he might be having number of parameters with him which might be working on which area I have to prioritize, which I should not prioritize. So like that he will be working on it. So based on that, finally he will come to a conclusion by applying this algorithm will help production engineers to avoid unnecessary uh, uh, applications on unnecessary data. Rather, you can avoid that. So you can simply avoid that. That could be really time consuming and that could provide the best outcome. I mean, the decision could be the best one where the outcome will be maximum. So this is the application of alpha beta pruning and minimax in oil and gas industry. Okay, so today we are going to end up to here, and let us meet for tomorrow's session. So these algorithms you have to understand when you are writing, when you are going through it. This can be done in softwares also. If the data is huge, if the data is small, you can just calculate how I have gone through one by one. So when you change the values at the child node, automatically the root node also will change. So based on your the values and priorities, the node values also will be altering. So altogether, this minimax and alpha beta pruning will follow DFS rule. So DFS means depth first search. So this is the prerequisite for this algorithm. So what is depth first search? Why we go in that alone direction? Why we can't go in that direction? You can watch the earlier concepts, like we already discussed about that. I'm going to share the video. So if you just go through that video, how depth first search, breadth first search have been formulated, you will be understanding. Based on that, you can able to consider this algorithm. Like if you start comparing that with this, you will be knowing how we have gone further and further. Okay, thank you for today's session, and tomorrow we are going to meet for data analytics and petroleum. Thank you.